Hello. In this video, I would like to talk about the fundamental theorem of algebra. If you recall, the solutions of a polynomial equation equal to 0 are located at the x-intercepts of the graph of the function. The solutions are also known as roots or zeros. Not all solutions will present themselves on the x-axis, but those that do are known as real number solutions. The fundamental theorem of algebra states that if p of x is a polynomial of degree n greater than or equal to 1, then the polynomial equation p of x equals 0 has exactly n complex number roots, including multiple roots at a single location. Oftentimes, we will use the graph of a polynomial to predict the number of each type of roots of a polynomial. Real number roots are located where the graph touches or crosses the x-axis, whereas imaginary number roots are not visible in a traditional coordinate plane. Multiplicity is the term used to describe when a linear factor appears more than once in a factored form of a polynomial. The behavior of a graph at the x-intercept with multiplicity n will be close to linear, or approximately a straight line, if n is equal to 1. The graph behavior will be close to a quadratic or parabolic if n is equal to 2, close to cubic if n is equal to 3, and so on. Additionally, the sum of the exponents of the factors of a polynomial, including multiplicity, is the same as the degree of the polynomial in standard form. Therefore, the sum of these exponents indicates the number of solutions to the polynomial equation. When a polynomial is factored, the solutions are found by setting the factors equal to 0. And if necessary, we will use the quadratic formula to find imaginary number solutions. Let's now take a look at 3 examples. In this first example, we have a graph of a polynomial that appears to touch or cross the x-axis 3 times. And if we look closely at each zero, the function more or less behaves like a straight line in each case. Therefore, we know the multiplicity is 1 at each location. By looking at the graph only, we would say that this function has 3 real number solutions. However, it is impossible to determine the imaginary number of solutions without an equation. If I were to tell you that the polynomial function represented by this graph is f of x equals x cubed minus 2x squared minus 5x plus 6, then we should recognize that this third degree polynomial only has 3 solutions, and that all 3 solutions are real numbers that are visible on the x-axis. And we would say that those solutions are x equals -2, 1, and 3. In our next example, we have a polynomial written in standard form. When written in standard form, we look at the degree to determine the number of solutions. This polynomial will have 4 solutions. Let's try factoring in order to find these solutions. First off, there is a greatest common factor of x squared. And after that is factored out, we're left with a quadratic that can also be factored. Since the first linear factor x has a power of 2, We would say that this factor has a multiplicity of 2. And when we look at the graph, we will see that the graph behaves like a quadratic function at that 0. Since we have the function factored, we can set each factor equal to 0 to solve for the polynomial solutions. The solutions for this polynomial are 0, -2, and 4. Notice that at x equals 0, the function behaves like a quadratic, whereas the function at -2 and +4 behave linearly. And again, our function contains only real number solutions because they are visible in the graph, but also we recognize that each solution algebraically was a real number as well. This solution had a multiplicity of 2, so it was counted twice. In our final example, we look at a function in factored form, where the first factor is x with an implied exponent of 1. The second factor is x minus 2 with an exponent of 2. And the third factor is x plus 7, again with an implied exponent of 1. The sum of these exponents is 4. Therefore, there are 4 solutions to this polynomial. We would set each of these factors equal to 0 to solve the polynomial. We find that the solutions are x equals 0, +2, and -7. The multiplicity of the second solution is 2. Therefore, the graph of the function will behave like a quadratic at this location, and the graph will behave like a linear function around the other 2 solutions. And here is an image of that graph. I encourage you to explore the graphs of different polynomials on your own and predict the solution before you graph to check your work. Good luck.